This is lesson 2 from Unit 9. We're going to be solving using trigonometric ratios today. If you haven't, go ahead and make sure that your calculator is in degree mode. Remember to check and make sure you're in degree mode. You just hit the mode button. Make sure that degree is highlighted. If degree is not highlighted, you need to arrow down there and arrow over to degree so that it's flashing, and hit the enter button so that you know you're in degree mode. Because if we are not in degree mode when we start this lesson, we're going to get a lot of crazy answers that people are going to think we've lost our mind when we do these problems. So what we need to do when we're using trig ratios to solve is we need to do two things. We need to A, decide which trig ratio we're going to use, and then we need to plug in the information that we have and actually solve the trig ratio, because there's something missing. There's a leg missing, there's a hypotenuse missing, there's an angle measure that's missing, and we want to find that missing piece of information. So the first thing we want to do is we want to determine which ratio we need to use. So we have triangle STU here, and angle S is our given angle, and it's 54 degrees. And then from angle S, side SU, because that's what we're looking for, it says find the length of SU. SU is what relationship to angle S? SU is right next to the 54 degree angle. It makes my 90 degree angle, so it can't be my hypotenuse. It has to be my adjacent leg. My adjacent leg makes my given angle and the 90 degree angle at the same time. Remember, the hypotenuse is opposite that 90 degree angle. And TU over here that measures 87, TU is opposite because we're standing here. This is the other side of the triangle. So TU is on opposite leg and it measures 87 degrees. So let's go ahead and write adjacent and opposite here. And then we need to decide what ratio we're going to use. We're looking for the adjacent leg because it's the one that has no measure. And we know the length of the opposite leg. So the ratio that uses opposite and adjacent is the tangent ratio. So we're going to use the tangent ratio to find this missing side length. So we start out by saying the tangent of the 54 degree angle, because that we know. And then we're going to fill in. And remember, tangent of theta is opposite over adjacent. So we're going to fill that in. Our opposite leg is 87. Our adjacent leg is the one we don't know. And since it's not marked with anything, we're just going to call it X. So what we need to do is we need to isolate X. Right now, X is dividing 87. So the opposite of division is to multiply. And if we multiply on one side, we have to multiply on both sides. So this X and this X cancel each other out, and I'm left with X times the tangent of 54 degrees equals 87. Now, here's where people start making mistakes. They want to divide by something that isn't there, or they only want to divide by part of something. We want to get this X by itself. This whole thing, this entire thing that says the tangent of 54 degrees is stuck to that X. That says X times the tangent of 54. It doesn't say X times tangent. It doesn't say X times 54. It says X times the tangent of 54. So we need to divide by the tangent of 54. And if we divide this side of the triangle or this side of the equation, we have to divide this side of the equation by the tangent of 54. So those two things cancel each other out, and they leave X by itself. And then we just take our calculator, and we could do this without a calculator, but in order to do it without a calculator, you've got to have this giant set of tables to do that, and we don't have those tables. So let's get my calculator so you can see it. And we're going to take 87, and we're going to divide by the tangent of 54. And we get this big long decimal. And if our directions don't tell us what to round to, we're going to round to the nearest tenth. So X equals 63 remember the tenths is the first place right there. That 0 says to leave that 2 alone, so 63.2. So the length of that missing leg is 63.2. We got double X's there. So we've got to identify our information. We've got to, and from that information, we have to decide which ratio to use. Don't just pick, don't just randomly guess. Identify what you know and go from there. Example number 2. A hospital must have access to a ramp, or must have an access ramp to a bay door that is 2.3 feet above the ground with a pitch of 8 degrees. Rounded to the nearest tenth, there we go, we got told what to round to there. Rounded to the nearest tenth, how long does the ramp need to be? So we're looking for this letter Z right here because that's the ramp itself. That's what we want to find out. So let's identify the information that we have. We know that angle A is 8 degrees. We know that the wall over here, which is BC, is 2.3 feet. The given angle, oh no, that's not what we want to know. That's not asking us. It says the wall is, and we want to decide, is it opposite, adjacent, or hypotenuse? Because it tells us the given angle measures 2.3 feet. So we got to figure this out. So from right here, you're standing in this corner. The wall over here is the opposite side of that triangle. So it's opposite the given angle, and it measures 2.3 feet. And the ramp, what's the ramp's relationship to this A? Well, the ramp is opposite the 90-degree angle, so the ramp is a hypotenuse. So we know the opposite leg. We're looking for the hypotenuse, because that's the thing we don't know. What uses opposite and hypotenuse? Sine. Sine uses opposite over hypotenuse. So we're going to set up the sine of theta equals the opposite leg over the hypotenuse. So the sine, we know the angle measure, so we're going to take the theta out and replace it with 8 degrees. The opposite leg, here's the opposite leg. You want to label your picture. Label your picture. The opposite leg is 2.3 degrees. The hypotenuse is labeled Z because we don't know the length of the hypotenuse. So we always are going to multiply by this denominator because this denominator is dividing whatever's on top of it. If this denominator was a number, we would multiply by that number. But this denominator just happens to be a Z. So we're going to multiply by Z. Those Z's cancel each other out and leave you with Z times the sine of 8 degrees equals 2.3 feet. And just like example 1, Z is not being multiplied by a sine. Z is not being multiplied times the 8. Z is being multiplied times the sine of 8 degrees. So we're going to divide by that entire thing. And we're going to do it on both sides, the sine of 8 degrees. Those two guys cancel each other out and leave you with nothing but Z. And then we go to our calculator and we say 2.3 divided by the sine of 8. And we get a big long decimal. We were told in the directions to round to the nearest tenth. So that 2 tells you to leave that 5 where it's at. So our ramp needs to be 16.5 feet long. Of all the things that we do, trigonometric ratios are probably some of the most useful things that we do. I know we do a lot of things that don't seem to make sense and you don't understand where you're going to use them. But trig ratios are something that if you build anything, you're probably going to need to use a trig ratio at some point. So example number 3, we want to identify what we're looking for and we want to identify the parts that we already know. Rounded to the nearest degree, find the measure of angle J. All right, well, angle J is right here. And since angle J doesn't have a number, we're going to call it theta for the moment. So remember, when we are looking for an angle measurement, we know the sides, we're looking for an angle measurement, we're going to use the inverse. But we got to decide which ratio is appropriate, and then we'll do the inverse of that. So let's figure out what our legs, we have a 46 leg and a 93 leg. I don't know if they're in feet or meters, but one of them measures 46 and one measures 93. So we need to figure out their relationship to angle J. So if you were standing right here and you walked over here to this side of the triangle, this is the opposite side of the triangle. So KL is opposite angle J, and is LJ the hypotenuse? No, LJ is not the hypotenuse. The hypotenuse is opposite the 90-degree angle. LJ makes the 90-degree angle, so that makes LJ the adjacent side because it makes the 90-degree angle and our theta angle. So opposite and adjacent. What ratio uses opposite and adjacent? The tangent ratio uses opposite and adjacent. So we're going to use the inverse of the tangent ratio. So the inverse of tangent is opposite over, not over hypotenuse, over adjacent. And we're going to fill that in. The inverse of tangent. The opposite leg measures 46. The adjacent leg measures 93. You're really going to like doing these. These are super easy because the calculator does all the work once you set the ratio up. So we go back into our calculator. We say the inverse of tangent. We go second tangent. Inverse of tangent, 46 divided by 93. And if you want to use alpha y equals to make an actual fraction, that's fine. It's going to read it the exact same way. So the inverse tangent of 46 divided by 93 gives us a big long decimal. Remember, our directions said round to the nearest degree. So that 3 tells you to leave that 6 alone. So the measure of angle J, is 26 degrees. Make sure you put the degree symbol because you are measuring in degrees. Anytime we know what we're measuring in, we need to note that in our answer. And when you see an M in front of an angle sign, it just means the measure of that angle. Told you would love finding angles. They're really easy. Put the numbers in the right spot and put it in your calculator. Example number 4 says rounded to the nearest degree, find the measure of angle A. Well, angle A is right here. That's where we're at. That's our theta angle. From here, we know this side and we know this side. This side we can automatically identify as the hypotenuse because there's the 90-degree angle. So let's go over here and read. Determine the leg's relationship to angle A. AC is right here. AC is the hypotenuse. And CB is all the way on the other side. So CB is the opposite leg from angle A. So if we're using the hypotenuse and the opposite, we're going to be using sine. So we're going to use the inverse of sine to calculate this missing angle measure. So the inverse of sine says, hey, put the opposite leg over the hypotenuse and put it in your big fancy calculator. So the inverse of sine, my opposite leg measures 5. My hypotenuse measures 10. You have to put this in the calculator. The inverse of sine, 5 divided by 10, is exactly 30. So the measure of angle A is 30 degrees. Take the time to identify the pieces of the triangle that you know and determine which ratio is the one that you want to use. We don't want to just randomly guess and hope that we get it right. We don't want to wait around for Miss Holman or Miss McCulley to give us the answer. We need to be able to do this on our own, and we need to have the trig ratios memorized because they're simple. If you'll remember that silly sentence, some old hippie caught another hippie tripping on acid. Works every time. A warehouse received a ramp, this is example number 5, to be installed at one of the loading docks, but no instructions for which dock. The ramp is 12 feet long. How high is the loading dock door if the ramp is at 11 degrees? So angle A is given to us, so we're going to have to find this missing number right here because we need to figure out which loading dock it is. So AC is blank, measures 12 feet. AC goes from here to here. What's AC's relationship to angle A? More importantly, what's AC's relationship to that 90-degree angle? What's on the other side? So this is my hypotenuse. It measures 12 feet. I'm going to go ahead and label it hypotenuse. And BA is right here. BA is the distance that the ramp extends from the base of the building, and it is adjacent to angle A. So I have a hypotenuse and I have an adjacent angle. So I had forgotten that I actually changed this question on your notes. These are some old notes. This question actually said to find the distance that the ramp will extend from the base of the building. So we're actually looking for this right here. That's what we actually want to find. And we're going to do that using not the tangent ratio that I just wrote down. We're going to do that using the cosine ratio because we know the opposite and the adjacent. So ignore my problem that says how high is the loading dock. I want to know how far away from the building will this extend. So I'm going to do the cosine. The cosine of theta is adjacent over hypotenuse. And we're going to fill that in. So the cosine, I know that that the angle I'm working with is 11 degrees. So the cosine of 11 degrees is the adjacent angle. That's the angle I don't know yet. That's the one I want, or that's the side I want to know, the adjacent side, over the hypotenuse that measures 12 feet. Now, this one is really simple to solve compared to the others that we've already done because we're going to multiply by the denominator. So we're going to multiply by that 12. Y is by itself. So all we have to do is say 12 times the cosine of 11 degrees. And we get a big long decimal. And we're going to round. Does it tell us what to round to? Nope. If it doesn't tell us what to round to, we always round to the nearest tenth. And we got this big long decimal, 11.77. So that 7 tells me to round that first 7 up to 8. So my ramp is going to extend 11.8 feet from the building. The last thing we want to look at in this lesson is trigonometric ratios of complementary angles. So you got to remember that complementary angles are any two angles that add together to equal 90 degrees. So in a 90 degree or in a right triangle, you're going to have a pair of complementary angles. The two acute angles in a 90 degree triangle are going to be complementary to one another, meaning that angle A, the measure of angle A, plus the measure of angle B equals 90 degrees. So there is a special relationship between those two, and it's just called the trigonometric ratios of complementary angles. And it says if angle A and angle B are acute angles in a right triangle, then the sine of angle A equals the cosine of angle B, and the cosine of A equals the cosine or the sine of B. They're just opposites of one another. So for this triangle right here, we need to solve, and we got to figure out the measure of the angle first. So we want to find the measure of our theta angle. So the measure of angle P is going to be the inverse cosine of 7 over 13. So that's going to be 57 degrees. So the rule just says this: the cosine of angle P is equal to the sine of angle R. And so we can take the cosine of 57 and we can say that's equal to the sine. And then because we don't know the measure of angle R, but we know it's complementary, we can say 90 minus 57. So the cosine of 57 is equal to the sine. Let's see, 90 minus 57 is 33. These two things are equal to one another. And if you put the cosine of 57 in your calculator, you get 0.545. And if you put the sine of 33, you get 0.545. So just know that if you calculate the sine of this angle, you can get it'll be the exact same thing as the cosine of this angle because we're coming at it from different directions.